This is Britt Caswell with another example video. In this video, I'm covering example 5 from section 2-7 in the SavvasRealize Algebra 2 textbook. In this video, we are looking at using a system to solve an equation. In fact, in this video, we actually focus only on using the graphing calculator in order to solve this. You'll have to look at other examples to look at how to solve it by hand. So what we have here is we have an equation that has expressions on both sides. And so what we can do is we can take the equation and we can split it into two equations. So here, this red stuff that I have, I'm going to call it f of x equals x squared plus 9x minus 5. And I have that graphed. That's what the red parabola is on my graph here. And then I can take this second half of the equation and I could call it some other function. I'm going to call it g of x. And that has been graphed with this blue line. So with systems of equations, you can tell what the solutions are where they overlap. So right here, these overlap here and here, and these numbers are super ugly, aren't they? But they are my solutions. So this method of graphing, it gets me approximated answers. Okay, those probably go on for forever. Alright, so it's not ideal. Now, if I actually wanted to solve this equation, personally, I would probably just use the quadratic formula. But you can do it with graphing like this. So again, if you want the exact answer, you got to use the quadratic formula. So here we are. Here's another example. So in this equation, I called my first function 3x squared minus 7x plus 4. And you can see that's the red parabola that's on my graph. And my second equation, I called it 9 minus 2x. That's what that was. Okay, so it's just each side of the equal sign. Okay, and so that's my blue line. So if I'm looking for solutions, again, I look for those points of intersection. And I'm getting these really kind of hideous numbers. So if you're looking for if you're looking for exact solutions, this method will not get you the exact solution. It just gets you the approximate values. Now understand, the solutions in this case, it doesn't care about the y values, okay? It just cares about the x. So I would say that my solution on this one is that x is approximately negative 0.703, and x is approximately 2.37. Okay, now the same thing as up here. Okay, the solutions are at x equals, I should say x is approximately 12.708, and x is approximately 0.708. Okay, and again, that's because the y values don't really matter here. The equation only has x's. But there we go. That is using a system to solve an equation. Until next time.